Good day, everyone. Today, we are going to have another new topic in physics under module number 4, which is entitled Unleash Your Potential. And the most essential learning competency is to apply the conversion of potential to kinetic energy and vice versa to given situations. Here are the expectations. Number one, describe potential and kinetic energy. Number two, calculate potential, kinetic, and mechanical energy. Number three, state the law of conservation of energy. And number four, apply the transformation and conservation of energy in reality. So this lesson is aligned with the division made module from the division of Caloocan. Energy is part of our everyday living. We need energy to work and perform our daily tasks. Energy in science is defined as the ability or capacity to do work. We can get energy from the nutrients of the food that we eat every day. And energy is being described as the unit joules. And the symbol for joules is J. Or joules is also equivalent to kilogram meter square per second square. There are many kinds of energy, like the solar energy from the sun, light energy from the bulb, lampshade, or fluorescent. We also have sound energy from the speaker or radio, and heat energy from the fire. Aside from that, energy can be chemical energy like the one that is present on the battery and food, or electromagnetic from the X-ray, and nuclear energy from fission and fusion. But all forms of energy can be grouped or classified into two categories, which are the kinetic energy and potential energy. What is the difference between the two? Kinetic energy is the energy in motion. It comes from the Greek word kinetikos, which means moving. Another classification of energy is called potential energy, which is the stored energy. Potential energy can be chemical energy, elastic potential energy, or gravitational potential energy. Moving objects like cars and other vehicles possess kinetic energy. And kinetic energy can be computed using this formula. One half of the product of the square of velocity and mass. M here stands for mass, while V is the symbol for velocity. Objects in motion is said to have kinetic energy like cars, motorcycles, buses, trucks, and other means of transportation. So for today, let us apply this formula in solving problem involving kinetic energy. Consider a 90 kilogram motorcycle moving at 50 meter per second. Let us calculate its kinetic energy. So, in solving problem in physics, we have to follow certain steps. So, let's start with the given. So, in this problem, we have 90 kilogram as the mass of the motorcycle and 50 meter per second as the velocity of the motorcycle. Next thing to do is to identify what is asked. What are we looking for? So for this problem, we are finding out the kinetic energy of the motorcycle. And we can do that by using this formula. Ke is equals to 1 half mb squared. So if we have now the formula and given, we can now substitute the given to the formula. So bring down 1 half, and the mass is equals to 90 kilogram, while the v or velocity is equals to 50 meter per second. And according to formula, we have to square it. And then bring down 1 half, bring down 90 kilograms, and square first 50, which is equals to 2,500. And if you square the value, you have to square also the units. So it will become meters square and seconds square. So bring down 1 half, multiply 90 by 2,500, and you will get 225,000. And just copy the units, kilogram meter square per second square. So the final answer will goes like this: 112,500 kilogram meter square per second square, or in short, 112,500 joules. So joules is the unit for describing energy. As I said a while back, potential energy can be chemical energy, elastic potential energy, and gravitational potential energy. So let us see how do they differ from one another. Chemical energy is the energy possessed by atoms or molecules of an object or substance and can be changed into other forms if there is a chemical reaction. Examples of chemical energy are present in some batteries, which stored energy, or battery of your cell phone and laptop, which also stores some amount of energy. Chemical energy can also be found in the food that we eat, which is stored in our body and later gives us energy in order for us to do our day-to-day activities. Another kind of potential energy is present in some elastic materials. That is why it is called elastic potential energy. Elasticity is one of the physical property of an object wherein it goes back to its original shape and size after being stretched. Examples of elastic materials are rubber band, slingshot, spring, and archery. They all possess elastic potential energy. So let us move on to another kind of potential energy. And the last kind is what we call gravitational potential energy, which is possessed by an object due to its position. Objects raised at a certain height, like this building, possess gravitational potential energy. Roller coaster is one example of objects where gravitational potential energy is present. And GPE is defined in science as the energy possessed by an object due to its position. And if you want to calculate the value of GPE, this is the formula. M here stands for the mass, G is for the symbol for gravity, and H refers to the height. You can multiply the mass to the gravity and height to get the gravitational potential energy. And though potential energy can be in several forms, gravitational potential energy will be the one of the focus of our lesson today. What are other examples of objects wherein gravitational potential energy is present? Skydiving, bungee jumping, or person in hot air balloon all have gravitational potential energy because they are raised at a certain height. Falls also possess GPE due to its position from the ground. What else? Coconut from a tree also possess gravitational potential energy. Mountain climbing, riding on a plane, or even person about to dive all have gravitational potential energy. As you notice, they all raise to a certain height because gravitational potential energy is affected by height and mass of the object and gravity. So what is gravity? Gravity is one of the familiar forces we are experiencing every day. Based on the theory of motion by Galileo, gravity is a force exerted by the Earth which attracts objects on Earth towards its center with an acceleration which is equals to 9.8 meter per second square. Gravity gets weaker as you go away farther from the planet because gravity depends on the size and location of an object. The farther you are from the center of the Earth, the lesser the gravity. And the closer you are from the center of the Earth, the greater the gravity. So gravity has something to do with the value of gravitational potential energy possessed by an object. So let us now solve some problems involving GPE. Consider a 1 kilogram coconut positioned at 10 meters from the ground. Calculate its gravitational potential energy. So we will have to follow the same steps starting from the given. And in this problem, we have 1 kilogram coconut and 10 meters height and the gravity is constant at 9.8 meter per second square. After that, you have to write down what is asked. So in this problem, we are looking for the gravitational potential energy of the coconut. And we can do that by using this formula. GPE is equals to mass times height times gravity. So using this formula, we can now substitute the value and the given. So GPE is equals to the mass, which is 1 kilogram, times the gravity, which is 9.8 meter per second square, and the height of 10 meters. And all you have to do is to multiply 1 by 9.8 by 10. And in doing so, you will get 98 and the units will be kilogram meter square per second square. So just copy kilogram here, then meter square, we have 2 meter, so it will become meter square and then bring down second square. And the final answer will be 90 kilogram meter square per second square or simply 98 joules. So, if an object is lifted into a certain height, the object possesses gravitational potential energy which is equal to the amount of work done. Letting the object fall will result in the decrease of potential energy and increase in kinetic energy. It means that the potential energy loss is equivalent to the kinetic energy gain, like this coconut from a tree. While it is on the tree, it possesses gravitational potential energy. But if the coconut falls to the ground, the gravitational potential energy of the fruit will be converted to kinetic energy as it falls. This is what we call law of conservation of energy, which states that energy can neither be created nor destroyed. It is just transformed from one kind of energy to another or transferred from one body to another, but the total amount of energy remains the same. Looking at the diagram here, you can see that the coconut falls to the ground. At the top, gravitational potential energy is at maximum level, which is 98 joules, while kinetic energy at the top is equals to 0. At the ground, GPE becomes 0, while kinetic energy is at maximum, which is equals to 98 joules. So in this drawing, you can notice that there is a transformation of 98 joules of potential energy to 98 joules of kinetic energy. So let us elaborate more. At the top, gravitational potential energy is equals to 98 joules, while the kinetic energy at the top is 0. So 98 joules here is the maximum amount of energy present in the coconut. While at the ground, the gravitational potential energy is equals to 0 now, while the kinetic energy at the ground is equals to 98 joules. So the sum of the potential and kinetic energy of an object in a conservative system is equal to the total amount of energy or the total mechanical energy. In formula, TME is equals to PE plus KE. So TME here refers to total mechanical energy. PE pertains to potential energy and KE is the symbol for kinetic energy. So the force is said to be conservative if the total work done in a particle in motion between two locations are independent from the taken path. It depends only on the object's position. So gravitational force is an example of what we call conservative force. So at the top, we can say that the total amount of energy is 98 joules, and that is equal to the sum of PE and KE. So, PE at the top is 98 joules. KE at the top is 0. So, 98 plus 0 is equals to 98 joules. So, 98 joules is the total amount of energy at the top. While at the ground, there is also total amount of energy which is equals to 98 joules again. Why? Because PE is equals to 0 at the ground here, while Ke at the ground is equals to 98 joules. So 0 plus 98 is equals to 98 joules. So whether at the top or at the ground, the total amount of energy stays the same. In this example, at the top, the total amount of energy is 98 joules. At the ground, the total amount of energy is 98 joules. So it is very evident here that the loss in potential is equivalent to gain in kinetic. And as the height decreases, the gravitational potential energy also decreases. So from 98, it becomes 0 because the height also decreases. So the height has something to do with the amount of gravitational potential energy. So this scenario also explains that energy is not lost. It is just converted from potential to kinetic energy. Therefore, energy is conserved because the total amount of energy stays the same. To elaborate more, let us have another example to show how energy is conserved. Consider the position of the ball at point 1, 2, 3. So from the ground, the ball is going up until it reaches its maximum height at 3 meters. And because of gravity, it will falls back to the ground from point 3 down to point 2 and then in its initial position at point 1. So at point 1, gravitational potential energy is 0, while kinetic energy is at its maximum amount. While in point 2, gravitational potential energy and kinetic energy are equal to one another. And here at 3 meters or at point 3, gravitational potential energy is at maximum level while the kinetic energy is 0. To expound this concept, let us compute for the value of potential energy, kinetic energy, and total mechanical energy. Let us have a table here. The first column belongs to the height. The second one refers to gravitational potential energy. The third column is for kinetic energy. And the last one pertains to the total mechanical energy, which is equal to the sum of gravitational and kinetic energy. So at point 1, let's say the height is 0 meter because it is on the ground. At point 2, the height is 1.5 meters, and at point 3, the height is 3 meters. Let us calculate gravitational potential energy one by one. I will follow the same procedures I did last time in solving a problem. Let's start at point 1. As usual, in solving a problem, we will begin with the given. So in our problem, the given are the following. The mass of the ball is 1.5 kilogram and the height at point 1 is 0 meter and the gravity is constant at 9.8 meter per second square. And let us see what is asked. We are looking for the gravitational potential energy or GPE. And the formula to be used is GPE is equals to mass times gravity times height. And because of that, we can now substitute the value. So our mass here is 1.5 kilogram. The gravity is 9.8 meter per second square, while the height at point 1 is 0. So multiplying 1.5 to 98 to 9.8 rather and 0 will give you an answer of 0 joule. So at point 1, the GPE is 0 since the height is also 0. Let us move on to point 2. At 1.5 meters, na given are the following. The mass still the same, which is 1.5 kilogram, while the height now becomes 1.5 meters since we are now in point 2, and the gravity is constant at 9.8 meter per second square. Again, we are looking for the gravitational potential energy. And then we are going to use the same formula and then substitute the value. Our mass is 1.5, the gravity is 9.8 meter per second square, and the height here is equals to 1.5 meters at point 2. So multiply the three quantities, 1.5, 9.8, and 1.5. And the answer is 22.05 joules. So meaning at point 2, the GPE is equals to 22.05 joules. And the last point is point 3. The given are the following. Mass remains the same, 1.5 kilogram, while the height now is at 3 meters and the gravity is constant at 9.8 meter per second square. And then we are looking for the same quantity, which is the gravitational potential energy. And we can use the same formula, GPE is equals to mgh. And in doing so, we can now substitute the value. So the mass here is 1.5, the gravity is 9.8 meter per second square, and the height at point 3 is equals to 3 meters. So just multiply the three quantities, and you will get 44.1 joules. So meaning to say, at point 3, the GPE is equals to 44.1. So you will notice here that at the maximum height of 3 meters, the maximum potential energy of the ball is attained at 44.1 joules. After computing the value of GPE, let us now proceed to the kinetic energy of the ball. And based on this diagram, we can be able to know easily the value of kinetic energy in each position, point 1, point 2, and point 3. So let's start with point 1. It says here that GPE is equals to 0, which is true. We get this on our calculation that at point 1, GPE is equals to 0, while kinetic energy is at its maximum value. So take note that the maximum height is 3 meters, which correspond to the maximum amount of total energy or the maximum amount of energy of the ball, which is equals to 44.1. So in this scenario, the total amount or the maximum amount of energy is equals to 44.1. So the maximum amount of kinetic energy is equals to 44.1. And at point 2, it says here that GPE and KE are equal to one another. So if there is 22.05 joules of GPE, we can say that KE is also equals to 22.05 joules at point 2 or at the center. And at the top, at the maximum point, the GPE is now in its maximum amount, which is 44.1, while the KE is 0. So you can jot down here 0 joule as the kinetic energy at point 3 or at the maximum height. So knowing the GPE, we can be able to know also the value of KE. And since we already have the GPE and KE, it is now easy for us to determine the value of total mechanical energy or TME. All we have to do is to get the sum of the two energies here, GPE plus KE. So at point 1, 0 plus 44.1 joules is equals to 44.1 joules. At point 2, 22.05 joules of GPE plus 22.05 joules of KE is equals to 44.1 joules. And at the maximum height, which is at point 3, 44.1 joules of GPE plus 0 joule of KE is equals to 44.1 joules. So in this scenario, you will notice that the TME or the total mechanical energy remains the same all throughout the position of the ball. At point 1, it is equals to 44.1 joules. At point 2, it is also equal to 44.1 joules. And at point 3, it is equals to 44.1 joules. So the total amount of energy remains the same, which is equal to 44.1 joules. The total amount of energy at any position stays the same. Point 1, point 2, point 3 are all equal to one another. So this is a clear manifestation that the energy is conserved. Energy is neither created nor destroyed. It is just transformed from one kind of energy to another kind. So from the ground to the top, there is a transformation of energy from Ke to Gpe, or from point 1 to point 3, transformation is from Ke to Gpe. From the top to the ground, there is also a transformation of energy from Gpe to Ke. Or at point 3 to point 1, the transformation is from gravitational potential energy into kinetic energy. So, it is very evident here that there is no loss of energy. Energy is neither created nor destroyed. The loss in Ke is equals to the gain in gravitational potential energy, while the loss in gravitational potential energy is equals to the gain in kinetic energy. And you will notice also here at the center that the amount of gravitational potential energy and kinetic energy are equal to one another. So in this table, you will observe as the height increases from 0 to 1.5 to 3 meters, the gravitational Potential energy also decreases from 0 joule to 22.05 joules to 44.1 joules. And as the height decreases from 3 to 1.5 to 0, the gravitational potential energy also decreases from 44.1 down to 22.05 and then to 0. So it means that the value of gravitational potential energy is dependent upon the height, because when we say gravitational potential energy, it is the energy possessed by an object due to its height or position. But in the end, the total amount of energy stays the same, remains the same, or the total amount of energy is constant. So that is what we call law of conservation of energy, wherein it states that energy is neither created nor destroyed, it is just transformed from one kind of energy to another or transferred from one body to another, but the total amount of energy remains the same. Let's conclude our lesson for today. I hope this topic is clear and helpful to you. But before we end up, let me remind you that every human being is a unique individual having unique potential. Whether hidden talents or skills, it should be unlocked, used, and developed. So believe in your potential, trust yourself, pursue your dreams and goals in life. And you can only do that by unlocking your potential, because God has given us talents and skills which we can use to enjoy living. So unleash your potential and know your worth. That's all for today. Stay safe and have a nice day.